It is given that a mass m carrying a charge q is suspended from a string and placed in uniform horizontal electric field of intensity E. The angle made by the string with the vertical in the equilibrium position is. So we know that if we are just keeping a charged particle in an electric field, so if it is a positive charge, if you are just keeping a plus q charge inside an electric field, let's say electric field intensity is E, then we know that this electric field will exert a force F, which is equal to E into Q in the direction of electric field. And instead of this positive charge, suppose if I am keeping a minus charge Q over here, then electric field will exert a force EQ in a direction opposite to that. So according to the question over here, we are having a charge. Let's say that charge is plus Q, which is kept inside an electric field. So electric field is going to exert a force of EQ in this direction, and the string is attached over here. So due to force exerted by this electric field, it will have some deflection with respect to this vertical line. Let's say this deflection is theta, and our aim is to find out what about the value of this theta. Other than the force exerted by electric field, we can say that weight of this object mg is acting in downward direction. Let's say the tension in the string is equal to T. So when we can take this angle is equal to theta, we can resolve this T into two components. This component is going to be T cos theta, and this component is T sin theta. For equilibrium position, net force should be equal to 0. That means this T sin theta should be equal to EQ, and the value of T cos theta should be balance the value of weight mg. So if you are going for equation number 1, by equation number 2, we'll get it as this tan theta is equal to EQ divided by mg, or the value of theta will be equal to tan inverse of EQ divided by mg.